So, hi guys. I was doing a question of Codeforces. So basically, it is not available anywhere in YouTube. So I decided to put this question, and this is so nice problem of priority queue. So question क्या कह रहा है? You are given a permutation of P of n integer 1 to n. Permutation is array where each element 1 to n occurs exactly once. Okay. Let's call a subsegment P of L R of this permutation special if PL plus PR is equal to maximum of PR. Please calculate the number of special subsegments. First line contains n. This is the constraint. That means we have to do the problem in O of n or O of n log n because constraints is high. Okay. So let's say example how we can do this. First, let's understand what the problem is saying actually. So problem is saying that you have to count the number of special subsegment, and special subsegment is what where like this is the case and this is L, this is R, and sum of the maximum, its maximum is M, max M. Then we have to say that L plus R is equal to M. L is value at this, R is this, and M is maximum value. So L plus R is equal to M. Okay, so it is like we have to go through each. If we look for the brute force, then brute force. Brute force, what it is actually saying that, let's say example 3, 4, 1, 5, 2. 3, 4, 1, 5, 2. So let's start with this point. Okay, let's make it L and go through this. Then start making it R one by one. Like let's keep this as R. Okay, so 3 plus 4 is equal to 7, and maximum is equal to 4. So 7 is not equal to 4. Okay, let's make this. So okay, then what is the maximum here? Okay, so L value is 3 and R is equal to 1. That means sum is equal to 4 and maximum is equal to 4. So 3 plus 1 is equal to 4. So 4 is equal to 4. Count increases by 1. Count. Okay, then we will move this as R. Okay, so now its sum is equal to 8 and maximum is equal to, maximum till here is 5. So it is not equal to. So count will remain same. Then we will start with this range 3 and 2. Its count is its maximum is equal to 5 and sum is equal to 5. So it is equal to 5. So basically this will increase the count to 2. Okay, so we have done using this as L. Now we will start doing this as L. Okay, if we take this as L, take this as R, and its sum is equal to 5 and maximum is equal to 4, not equal, then we'll move to this. Its sum is equal to 4, 5, 9, and maximum is equal to 5, not equal, then move to this range, and this is 4 plus 2 is equal to 6, and maximum is equal to 5, which is not equal, so it will give no count. And then we will start using this as, okay, so now start doing, making this as L. This as well, and we will see sum is equal to 6 and maximum is equal to 5, not equal, not equal. Then we'll see this sum is 3 and maximum is equal to 5, so not equal to. So and then we'll start this as L, put this as L, then its value is equal, then R is equal to 2 and L is 5, so L plus 5, 5 plus 2, 7, and maximum is equal to 5, not equal to. Total count is equal to, what? 2. So answer 2. Okay, but have you noticed one thing, that we have taken two loops, n square, one for L and another for R. Okay, so how it is giving of n square, let's see. So this will be brute force code. So this will be the brute force code, and okay, so this is taking O of n square. And how can we improve it? So let's move on to the next method 2. So have you noticed one thing, that let's see the example once again. Okay, so So let's move on to this example using another method. Like we will start going through the biggest number. Like we know it is permutation of 1 to n. It is permutation of 1 to n. So let's move on with n, taking this 5. Okay. So we will ask 5, is there a greater element than you? It will say no. So it will take whole left. Then it will ask this whole right. So these elements will be L for this value, taking it as max. We are taking max as value and searching for its L and R. Okay, then we will move to the smaller side of R, like smaller side of R, and find the need. Like we iterate this, like you have 2 and maximum is 5. We know the formula L plus R is equal to M. So R is equal to M minus L, or M minus L, or L is equal to M minus R. So this will be the formula. And here we have M5. We have taken M5 minus 2. So is there any 3? Yes, we know there is 3. Okay, so count is increased by 1. Then we will move to the 4, like maximum, taking maximum as 4. After 5, we'll take 5. 4. Okay, so if you are maximum, is the previous greater element. Okay, so previous next greater element. So it will take this much. Okay, let's change the pen. So this is going to take this much of array. It will decrease because if we are here, then it will automatically give maximum as 5. So we want 4 as maximum. So this array will be having 4 as maximum. Now we will move to left and right. So this will be right and this will be left. So both are equal. We can move forward with any of the length. Okay, so if we take 3, so a 3, how much need is there? 4 minus 3. So is there any? So it will ask, is there anywhere in R having 1? Yes, I have. So count will increase to 2. Count increases. For this it was 1, and then again for this it will increase 2. Then we will move, then we have done with this 4. Then we will start using 3. So okay, so we will start doing with 3. Okay, we have taken 3 as this, and we'll say that is there any element? No. Is there any element? No. So it will not move. Then we'll go to 2 and ask for previous greater element. It will say yes, this will be the length. So this will be the array. So it will say, are you, which is the smaller? It will say that R is smaller. So move forward. There is no R. Okay, so then it will move with 1. So taking 1 as maximum, so there is no L, no R, so it will remain count as 2. So it is basically very easy. What we are doing, let's write it. First, we are finding the previous great. What we are doing? First, finding the previous greater element and next greater element. Let me write the code for you. So what we are doing, we are finding the previous greater element, then next greater element, then storing the position for O of one such, and then using the O amortized loop like. Okay, so we are taking M as 5, then 4, then 3, then 2, then 1. Then we are taking its L and R from the previous greater element and next greater element. So after having this, we're moving from 5 to 1, means N to 1. So it will automatically decrease the subarray like L value and R value, and we are moving it to, so it will give O of N time complexity. So it will give O of N time complexity. Let's move on to the code. So now I will write the code for you. Okay, so we'll be having N dot next int, then we are having values. It is, and then okay, and we need a position array so that we can find the position of any array in O of 1, any value, because we are having permutation of n plus 1, so value is basically from 1 to n. So position of p of I is equal to I, and we will write the previous greater element code here. This is using stack, and this question was given in priority queue playlist of Striver sheet. So okay, so we'll move forward like this. It is finding the, this is going to find previous greater element, greater element, stack with file st dot sm and file not st dot and P of st dot p is लेस देन इक्वल टू p ऑफ i, तो हम st डॉट ऑफ करते जाएंगे। एंड आफ्टर दैट अगर st खाली, हमें प्रीवियस ग्रेटर एलिमेंट की वैल्यू भी तो रखनी पड़ेगी। तो ये करा और ये कर दिया, ठीक। और अगर st डॉट, अगर st डॉट इज एम्प्टी है तो हमारा पी जी ऑफ i इज इक्वल टू 0, एल्स पी जी ऑफ i is equal to st dot peak. And what we will put in st? It is going to be st dot push I, right? And similarly, we will do for next greater element. Let me write it for you, next greater element. And st वही यूज कर लेते हैं, इसे क्लियर कर देते हैं st dot clean। और ये हम लास्ट से चलाएंगे, ये कोड तो बहुत ईजी है, हम ऑलरेडी पढ़ चुके होंगे अपने प्लेलिस्ट में। तो पी ऑफ आई, ये तो सब सही है, बस हम नेक्स्ट ग्रेटर एलिमेंट में n+1 डालेंगे, n+1 और नेक्स्ट ग्रेटर एलिमेंट में st डॉट पी, और फिर ये हो गया हमारा नेक्स्ट ग्रेटर एलिमेंट। अब हम कोड रन करेंगे और इंटीजर मैक्सिमम वैल्यू स्टार्ट करेंगे, m ग्रेटर देन इक्वल टू 1, m माइनस माइनस मैक्सिमम तो हमारे पास है, फिर l क्या होगा, l होगा प्रीवियस ग्रेटर एलिमेंट ऑफ, फर्स्ट वी हैव टू फाइंड ये मैक्सिमम वैल्यू की पोजीशन क्या है, तो उसकी पोजीशन लिख लेते हैं, पोजीशन ऑफ m। हम a ऑफ 1 में फाइंड कर लिया, अभी मैंने बात की थी इसकी, तो प्रीवियस ग्रेटर एलिमेंट ऑफ k, उससे आगे तक l चलेगा और r का चलेगा नेक्स्ट ग्रेटर एलिमेंट ऑफ k -1, एंड विल फाइंड द लेफ्ट लेंथ इज इक्वल टू pg, okay, k minus l plus 1, this is left length, right length is equal to r minus k plus 1, so if left length is less than equal to right length, हम लेफ्ट लेन में जाएंगे, लेफ्ट साइड फाइंड करेंगे वैल्यू और नीड सर्च करेंगे, तो हम फॉर इंटीजर i इज इक्वल टू l से i लेस देन इक्वल टू k तक जाएंगे, i प्लस प्लस, और उसके बाद हम क्या करेंगे, नीड हमारी क्या है, नीड है कि हमारे पास मैक्सिमम है माइनस p ऑफ i, अगर नीड हमारी लेस देन 0 है, लेस देन इक्वल टू 0 है या ग्रेटर देन है, तो हम कंटिन्यू कर जाएंगे, हमारे पास ये वैल्यू नहीं है, एंड सेल लिख लेते हैं इज इक्वल टू 0, ओके। और उसके बाद अगर पोजीशन, अब हमें ये फाइंड करना है कि जो हमने नीड निकाली है ये हमारी राइट साइड में अवेलेबल है कि नहीं इस पोजीशन में, सो आर ए से आर के बीच में अवेलेबल है कि नहीं, सो पोजीशन ऑफ नीड इज ग्रेटर देन इक्वल टू के एंड पोजीशन ऑफ इज लेस देन आर, लेस देन इक्वल टू आर, तो हम काउंट बढ़ा देंगे, आंसर बढ़ा देंगे। अब सिमिलरली हम अगर राइट लेंथ छोटी होगी तो उसके लिए कर लेंगे, ए से लेस देन इक्वल टू आर, तो अगर नीड ये आ गई, अगर नीड जो है लेस देन इक्वल टू के एंड ग्रेटर देन इक्वल टू एल पे, तो आंसर बढ़ा देंगे और हम फिर आंसर को प्रिंट कर देंगे, और हम इसका चेक कर लेते हैं ये कोड सही देगा कि नहीं।
So this is correct.